Welcome, Hornets, and thank you for joining me today. We are going to be taking a look at finding average values over a given interval, and I'm going to be using the average value worksheet number 2. This was given to CP class today, and we started working on it, and I'm going to be going over it and helping individuals work on it using these problems. So if you are interested in participating with me, please take a moment and do a screenshot so that you can have these with you and then try to do them. I would pause the recording so that you have the opportunity to try them before you see the answers. All right, let's go ahead and begin. So we're going to be starting with number 1, and then we're going to go through 2, 3, 4, 5, 6, 7, and 8. So here we go. Starting with number 1, we have, and I recommend that you set it up using your endpoints, -2 to 2. We're going to put our 4 minus x squared inside dx, and we are dividing by 2 minus -2. We end up getting 1/4. Now, when you do this, please put the 1/4 in front. You'll find that to be the easiest. -2 to 2, and then I have the 4 minus x squared dx. I'm now going to integrate, and I have 1/4 bracket 4x minus 1/3 x cubed, and I'm going from -2 to 2. I'm now going to plug in, and I get 8. I then have minus 8/3. Then I'm going to be subtracting, and I plug in the negative, and this is now giving me minus -8, and I get a double negative to be a plus 8/3. Now you'll notice that's going to give me a double negative here and here, giving me 16 minus 16/3 times 1/4. Now if you get the common denominator, you are looking at 48 minus 16 divided by 3 multiplied by 1/4. And this is giving you 32/3 times 1/4. And you end up getting 8/3. And therefore 8/3 is my answer. Now, I do recommend that you check your answers by working with your calculator, but that is up to you. We'll be taking a look at that in another video. We're now going to go to number 2. Number 2 is giving me an f of x, and the f of x is 4x squared plus 1 divided by x squared. Now, you'll notice in this function, we do have powers of x that are equal, so we're probably either going to have to do long division or separate it into 2 functions and simplify. All right. Let's just go ahead and see how that's going to work. I'm going to take out the coefficient, leaving me with the x squared plus 1 divided by x squared dx. I am working over the interval from 1 to 3. So I have 1 to 3, and I take 3 minus 1. There's my setup. This 1/2 is going to come out to the front, so 1/2 times 4 times the integration 1 to 3. And I'm going to write this as x squared over x squared plus 1 over x squared. This is separating into 2 fractions. This is a little bit easier than doing long division, and something that I would prefer to do instead. So I then have 2 integration 1 to 3 of 1 plus x to the minus 2nd power dx, and I'm now going to integrate. I get x plus, this is going to now add 1 and divide by the new power to give me negative x to the minus 1. And this is going to be from 1 to 3. I'm going to start by plugging in the 3, and I have 2. 3 minus 1/3 minus 1 minus 1. These cancel, and I'm left with 9/3, so I'm getting the common denominator. 9/3 minus 1 is 8/3 times 2 for 16/3. All righty, let's move on to number 3. Number 3 gave us a function that is 2e to the x over an interval -1 to 1. So we're going to set it up from -1 to 1. 2 moves out in front, e to the x dx divided by 1 minus -1. I'm getting a 1/2 here. Notice it's in the denominator. So I'm going to call this 1/2 of 2 times the integration from -1 to 1 of e to the x dx. And we know the integration of e to the x is e to the x. So I'm now looking at e to the first power minus e to the negative first power, which is e minus 1 over e. Now be aware, if you're in AP Calculus, you are going to have to get the common denominator called e squared minus 1 over e, and they're probably going to have you factor it into e plus 1, e minus 1 divided by e. Individuals in CP, this would be our answer, and we don't have to worry too much about it. Let's go to number 4 now. Number 4 is giving me f of x. F of x is equal to 1 over 2x, and the interval is 1 to 4. So I'm now going to take, now be aware this 1/2 x, this is really 1/2 times 1 over x. You see that? That means that when I put it in, the 1/2 is coming out in front. I'm going from 1 to 4. I have 1 over x dx. This is our logarithmic rule here. I have 4 minus 1. 1/3 comes out in front of the 1/2. Integration 1 to 4, 1 over x dx. And I now use 1/6 natural log absolute value of x from 1 to 4. This is giving me 1/6 natural log of 4 minus the natural log of 1. And we know that the natural log of 1 is 0. And so my answer is 1/6 the natural log of 4. All right, let's go ahead and move on to number 5. Number 5 gives me the function f of x equals the sine of x. And it's going from 0 to pi. So I have the integration from 0 to pi of the sine of x dx divided by pi minus 0. Now when we bring this up, this is going to cause 1 over pi times the integration 0 to pi from sine of x dx. And we know that this is going to give me a negative cosine from our rules from 0 to pi. And now when I put this in, I'm putting in pi. That's giving me negative 1 over pi cosine of pi minus the cosine of 0. And we know that this is negative 1 minus 1 for negative 2. And we have negative 1 over pi. So I'm looking at 2 over pi. And that's my answer to number 5. Number 6. Number 6 is working with the cosine of theta. That's our f of x. And I'm working with 0 to pi over 2. I'm now going to go ahead and set it up as the cosine of theta, d theta, integrated 0 to pi over 2, and I have pi over 2 minus 0. Now when I bring this up, because it's a fraction in a fraction, it's going to become the reciprocal. And I'm now right into process 2 over pi sine of theta from 0 to pi over 2, and therefore I have just 2 over pi as my answer because I have 1 minus 0. Now this is the end of part 1, as I'm going to have to finish the second half after my staff meeting. So please, I hope you enjoyed this first part of the first 6 problems, and hopefully you will see part 2 where I finish the last 2, 7 and 8. Thank you very much, Hornets. Please be safe and take care. And I hope you enjoy it. If you do, please click like. If you have suggestions for how I should do this, please feel free to put suggestions in so that I know how I can improve. Thank you very much and be well. Bye-bye.